All right, good morning, everybody. Thanks for coming out for this quick hitter. This is going to be on furnace quick sheets. So this is going to be our Gensco startup sheet, the furnace side. Jim Stevens, one of the other FSRs, and another one will cover the refrigeration side, how to fill it out and whatnot. But we're going to go over the furnace side today. So, of course, the 253-620 number you see 8282 is our main tech line number. So if you don't have that, write it down, put it in your phone. You can call or text it, and that's going to be how you get on-site support if you're out in the field. If you didn't know, now you do. So 253-620-8282 is our main line. All right, let's get into the furnace quick sheet. So obviously we're just doing this side today, so this is going to be a relatively quick hitter. But we're going to go over kind of how to fill this out and how to look at these individual boxes, because I know when I started people off, and even when I started, this was pretty intimidating. How much is too much? How little is too little? When you're handing off information to have someone look at it, right? So we're going to break this down, try to simplify it, make it more digestible. All right. So as we break down this form, right? So we should fill out the form completely, right? It's going to help us diagnose what's wrong with the system. It's also going to be a great data collection point. According to Gensco's standard operating procedures that Trane has given us, and we've decided on what we're going to do with Trane and our American Standard in that partnership. In order to get a job site visit from an FSR, we should, and we normally do, get this form filled out. Now, sometimes we bend the rules because we have to take care of our customers, being you guys. Of course, we want to make sure you get your customers taken care of. We bend this rule often, probably more often than we should. So we really should have this form filled out. It is a part of our standing operating procedure at Gensco. Obviously that gets bent quite often, but we should get this form filled out because this is a great data collection tool. We can simply get this filled out completely, hand it off to your local Gensco FSR, whoever that may be, me, Michael, Samuel, Jim, Derek, any of us, and we can start diagnosing, help you break down what's on this information sheet, especially when you get into the other side of it, if we got a refrigeration problem. So we want to make sure we fill it out as completely as possible. So that's listed about 3 times in this slide deck. All data must be recorded, otherwise there's a good potential for a misdiagnosis. We may miss something. Sometimes when we get these tech forms back, we just get the very standard answer, especially when it comes to airflow and such like that. We get that it's a 0.5. We don't want you to tell us what we want to hear. We want to know what it actually is, right? Even if it's bad, we need to know, because that could lead into some of the problems or maybe the sole problem that we're looking at. So we need it to be an honest representation of what you found that day. So like I said, we've never really turned down a site visit for not having this, but according to the rules between Trane and Gensco, we could. Don't see that ever being a point of contention to take care of a customer. So let's break down this individual. Let's go with the basics, right? So day of service, what day are you there, right? Then who's our on-site contact? Who is the homeowner, right? Okay, contact info of company providing any kind of service. So service tech that was out there that day. This is a Dan Smith home with John as the service tech on today, 3/20/24. We're going to put the company down, right? Because when you hand this form off, it may come through an email. Someone doesn't recognize. They're going to go, okay, this is such and such heating. This is the service tech. Maybe I'm familiar with him or not, or her. Of course, address, right? So who is the company providing the service, just in case there's questions. If we need to call and talk to that service tech about the address, maybe if there's an AUID tied to it, maybe put that in there somewhere in the form. So of course, we want a service location and contact. Who is the equipment homeowner? right? What's the physical address of the equipment? Maybe a good phone number for them. So we're basically just collecting data here, right? Who you are, why you were there, or not why you were there so much, but who the service tech that was there, and then where you guys are located out of, right? And then of course the equipment owner, address, zip, all that. Okay. So what's the first thing that happens when you go to the doctor? They're gonna do what they always do, right? They're gonna weigh you. They're gonna maybe do a height on you if you haven't been in there a while. Uh, depending on what you're going in there for, they're gonna basically interview. Have you had any ailments lately? Anything hurting? Anything sore? Right? That's kind of what we're doing here. We're collecting data that we can easily find. So we're gonna put down all equipment information. What is the outdoor unit model number, serial number, right? Air handler models, serial numbers, coils, furnace models, thermostats used, if it's got zoning, what kind of zoning does it have? Is it a Honeywell maybe with bypass? Any other accessories, right? Humidifier, air cleaner. So the reason why this is pertinent information, especially if you're going to bring in technical help, whether it be Gensco or your service manager or however your tiers work at your company. Maybe you put the outdoor model number, maybe you put the furnace model number, and we know that has a coil because it has some kind of HVAC or heat pump or air conditioning system tied to it. So we already know there's a coil there. So as a technician, we make some assumptions. Well, they're going to know that there's a coil, so why write the coil number down? Well, maybe we have maybe you hand a form off completely filled out. You hand it off to tech services, like, man, I've got this refrigeration problem and I can't figure out what's going on. We're adding gas, we're taking away gas, depending on the season. And since I have all the models and serial numbers, I can look and go, hey, this was never a matched approved unit. That coil was never made to run that side discharge 19 SEER or what have you, right? So right there with just data, we can find some stuff out, right? Just with the model numbers of the gear that's there. Also, maybe if we have an airflow problem, if we know how many zones, we know it's zoned, that may be something we can look at, right? So really good data collection here, just to be able to give us a whole rundown of what the system's going to look like. So all models and serial numbers of equipment on site. If we don't know the install date, just use the manufacturer's build date. Okay, so we're just going to put the serial number of the unit, and then we're going to use the installation date from the manufacturer. But you can pick a piece of gear, right? That's going to put us in the time frame, unless there's a lot of mix matching there. But the serial numbers will be able to tell us that. So, okay, so issue service history. Maybe you're the first guy, maybe you're the third guy, right? Or gal. So data collected here, hopefully you won't make the same mistake twice, right? So let's say the first technician made a repair, filled out this sheet, completed it, and then they changed, say, the main control board. Well, then the second technician comes out, has this data sheet and says, okay, I have the same issue as before. Here's everything that was checked. I'm going to go ahead and go through my checks and fill out another form if need be. And if it doesn't make sense to me, or I am at the same impasse as the last technician, then maybe I need to escalate this to somebody and they can look at the two data sheets and get me a direction that's different than the first tech and now the second tech, right? So think if you saw the notes from the previous call, the main control was already changed and there's exhibiting the same issue. This would hopefully cause you to dig a little deeper, right? At least it should make you think about it because you have the information in your hand. I know with Service Titan and whatever programs most people are using these days, a lot of that is at their fingertips, which is amazing. But when you're handing off that information to like Gensco Tech Services or something, we don't have access to that. So having these filled out completely as possible, especially if you're trying to bring or drag in outside help, is a huge win for us. Okay, so we can kind of see what's been done, whether it's one time or multiple times that technicians have been out there. All right. So as we start doing data collection from the furnace, we can look at, as we start applying the info to the sheets, right? So in this situation, we've got 122 volts. If you were to look at it from black to white, We have control voltage of 24 volts, so that's good. So we got a transformer that's hot and making what we need. But there's something really funny here. We have 80 on neutral and we have 42 on ground. There's a problem there, right? So just putting the information down is making you think about it. You're writing down, you're looking at, go, wait a minute, that's not right. I would say most of the time when we send these tech sheets out from our tech side, we hardly ever get a call back on them. Because what happens is you guys go out in the field and you start filling them out, like in this situation. And you realize, oh, it's right there. There's the problem, right? As you start putting the data on the sheet. So we have some issues that's gonna happen, right? So we shouldn't have anything on neutral. We're gonna have erratic codes, flame sense problems. Some situations, especially in the old 40s, since white is unchecked power, we could have some erratic motor operation, just like an inducer motor turning on for no reason, or a blow motor tapping on. So just with this little bit of information, we've already found a problem, right? So let's get into on the 40-inch furnaces. You have a barb fitting you're going to have to get into. On the newer 40-inch, they have a boss, right? A pressure inlet boss. They are sealed combustion on the old 40s, so they have a door over the burner, and you have to reference the burner, right? Or you have to take the door off the burner to get a true number gas pressure rating, right? So if it's a barb style, you're gonna have to get into it. If it's an inlet boss, you're gonna have to unscrew it and stick your hose over the top. And we're simply gonna put the inlet gas pressure and the manifold gas pressure. So inlet is what's coming in from the house, right? Can't be over 14 because we can't open our gas valve. Natural gas, obviously, NG and LP are going to be different. So, and then of course, if we have a two-stage unit, low pressure, low stage pressure we want to know, and of course the high stage pressure we want to know. So we're going to, depending on how we're mounted up, if it's a S9 V2, S8 V2, that's an open vestibule burner. So we don't have to reference the burner like the 40-inch with a sealed vestibule burner. So really that's the two differences, right? Sealed combustion, we have to reference the burner. S8, S9 with open vestibule burner, we do not have to reference it. Okay, so of course we want to know what fuel type. If the LP conversion was done, was it derated for altitude? These are all important. This is very important information to put on. So we have natural gas or LP. You can check either one. Of course, what orifices are in it, right? Depending on your derate or what you're trying to do, you may have to change spuds, right? You may have to set the gas valve differently, depending on what kind of derate you're trying to get done. So if you derated with spuds, we're going to want to know that. We're going to want to notate that. It went from 53s to 56s or whatever that looks like. So of course we got different gas pressures for natural and propane. So like first stage on most 40 inches, it's going to be 6 to 10, right? Natural gas is 1 to 7 to 3 to 5. So, and of course they're model specific, right? So in this reference, I'm just using a 40-inch furnace. So we want to know if we have a derate in place, if needed, what spuds maybe, and also if there was a derate for spuds, we want to know. So great data collection. So the advice on the current valves, S9V2s, are the White Rogers J valves. And these are the 36J single or two. So most of the 40 inches have moved over to this style valve. Of course, the S8s, S9s are all this style valve as well. So remember, with the 40-inch cabinet, we still have to reference the burner. Doesn't matter the gas valve change. If it's an older style with a barb, you're going to have to barb into it. These newer styles, you have the inlet pressure boss. So you simply loosen the screw. You don't have to remove it completely. And then place your hose over it, and you can pull your pressures from there. So on the left, it's the single stage. So you have the little brass or sometimes aluminum, depending on the valve manufacturer. Most of them are brass. You have your first stage low manifold pressure adjustment. So you remove that cover. You can make your adjustments to your pressure. and then you can put the cover back on to make sure it stays accurate. Or most technicians just use the thumb, put their thumb over it to make sure it's stable before they put the brass cap back on. So, of course, the one on the right is two-stage, so you have a low and a high. So really the only change there is an extra pressure adjustment, right? So still has the inlet pressure box in the same spot and the outlet. So we just have an additional stage. Okay, so mod furnaces. This is the only way you can adjust a mod furnace. They have some special piping in them, quite a bit of piping actually. And so the only way to set these up, check them, is to actually reference the burner and barb in exactly like this. This is the only way you can, I would even recommend if you change an inducer motor or a control board, doesn't matter if it's the skinny little board or the large control board, always do gas valve maximum setup, because it can give you a PS1 failure, because when you do the gas valve minimum maximum setup, it actually sizes the flue pipe that you ran to the inducer motor speeds, and it correlates those. So if you never do gas valve setups, min and max, and you never do this at all after an install, you're going to have some problem. It may work for a while, it's going to complain, but eventually you're going to get a call on it. So make sure you do this. If you're going to do a tune-up and you are checking gas as part of your tune-up procedure, you're going to have to pipe in like this to be accurate. Okay, so it is the only way to check a mod furnace. So other system info, right? What errors did it have upon arrival? When you go through the S9 readout, what does it got? What are the display? What is the display telling you? Write them all down. 3.2, 3 point whatever, write it down. We want to know. Was it repeated over and over again, right? 3.1 X2, right? So we had 2 of those. Any error codes on the thermostat? Definitely. On the variable speed products, we have more codes we actually hold in the outdoor unit. So let's say you get a 18407, 18408 at universal and a max. That's all it's shut the customer down, so it lets the customer know. But a lot of the times there's all the fault codes, 15 or so, held out in the outdoor unit. So a lot of the times when guys call in a tech with those 2 error codes at the thermostat, especially variable, that's the first thing we'll do is send them to the outdoor unit. Let's start writing down the outdoor unit codes, right? Because we can find commonalities and failures. Oh, look, it has a bunch of dome sensor hits, or we have compressor derates because of the sensor issue or a charge issue. So we can really break down, write them all down, write everything you can down. Of course, how does the unit drain? We need to know, is it a gravity, is it a pump? Do we have a safety switch maybe with a pump that's interrupting, breaking our call? It's good data to know, right? So could there be a safety switch holding operation? Maybe even if there's a wet switch sitting in a pan. Maybe the furnace is in a pan because of its location and it has a wet switch. Write it down. Yeah, wet switch installed. And maybe how that wet switch breaks. Wet switch breaks red. Wet switch breaks yellow. Whatever that looks like. So the more data you put down, the better off everybody is. All right, so venting system. What does this tell us, right? Of course, it can tell us if it's sized incorrectly, maybe too long, overfire, underfire, any kind of short cycling issues. So is it direct vent, non-direct vent? What's the size? How many number of elbows, right? Because we have to account for elbows, especially at 90%. What's the flue temp? What is that flue temp telling us? So an example of flue temps, 80% efficient for 300 to 400 degree range. That's a good 80% furnace burn temp. 90 plus efficiency, depending on how much of a plus it is, we're going to be between 110 and 125. So we can get a lot of information out of that. Let's say we pull a flue pipe temp out of a 90%er and it's reading 140. And we're getting scaling in the heat exchanger. Well, we don't have a heat exchanger anymore. We have essentially a boiler, right? So we can have some buildup in that secondary heat exchanger we don't want. So that can tell us some stuff, right? So we're collecting data to try to figure out if there's an issue here, whether it be sizing and all that. So like the S9V2 furnace with a PS is a PSC standard flue pipe motor. So when you talk about D-rate for elevation, you actually we don't have a D-rate kit with a pressure switch like we would a variable speed inducer motor because we have a PSC motor. So in a PSC motor, we're going to shorten our flue tables, right? So you get up in the 2,000 to 5,000 feet, we're going to allow less pipe, right? Or you're going to have to go to a larger size to get the distance required. So with PS model inducer motors, we simply reduce the venting tables with variable speed. We have switches and stuff that will have to be added as a kit. So this is all really good information to put in here. So if you called me at Tech Services and said, hey, I've got this thing, I've got this flue temp, I have these error codes, and we can go back and look at the install guides and try to figure out, okay, that wasn't an allowable size, right? Or too many elbows over so much length. Now we shouldn't be 2-inch, we should be 3-inch, depending on the application. So it can tell us a lot. Okay, also too, type of ignition, spark, is it a spark? Is it hot surface igniter? Most all of our train stuff, other than commercial maybe, is going to be hot surface, whether it's carbide that you see here. You see how we also have nitrides, right? So we did run 80 volts for quite a while in the older mods. We're pretty much out of the 80 volt market, but there's still enough of them out there, right? We've had them for years. There's plenty of them out there. Then we have the 120 volt that we're using in most all of our gear these days, or all of our gear these days, I should say. So we have ohm ranges for them, right? So 120 volt silicone carbides, 40 to 75 ohms at room temp. So what's this going to tell us if we're doing this as a tune-up, right? Well, if we have 100 ohms, 100 plus, maybe 150, that igniter's getting ready to go, right? So we have also 80 volt igniters, silicone nitride, 11 to 18 ohms at room temp. So this is essentially going to be the same thing, right? If we have 26 ohms, that igniter's getting old, it's going to have a problem. So writing all these down, especially if we're having an issue with some of the S9V2s can throw a code for an igniter problem. So if we know the ohms of the igniter or what it should be, we can simply go, okay, is this a control board problem or igniter? Ohm it out. Let's say the 120 volt red at 40, it's a board problem, right? Something going on with the board. So this is really good data to digest as well. Okay, so flame current and legacy models. So these legacy being 40-inch furnaces. We have to put in a jumper like this to get between the two, to put between the meter, and we're going to get microramps. Okay, so 1 is a minimum for microramp to hold the burner on, and then 2 to 3 is typical, if not 4. So we're going to have to get our microamps this way on the legacy models and most manufacturers for the most part. Okay, on the S model furnaces, we give you nice little paths there that you can put your meter to. So you can simply get it from there with the unit running, no jumpers, nothing special. I will say that they do kind of put like a glossy epoxy across the top of that, and you may have to kind of scratch that epoxy to get to those pads to get an accurate reading. But we're giving it to you on all of our models. Even the new S8V2 that's all linked still has this. So remember, 1 volts DC minimum, right? 2 to 4 typical. So we have seen situations where we're getting the voltage and the burner's still blowing out. It happens. We get the call, and of course, we're going to ask you to check for grounds. We're going to ask you to check for high voltage, make sure it's on the correct side and whatnot. But then we're also going to say, make sure you pull the burners and clean them, because everything grounds at the burner. So if your burner's dirty or anything there on the transfers, the actual flame shapers and all that, that can create a problem or feedback to our ground, which would knock out. You would still see the two or four, but it would knock out that ground. So make sure your burners are clean if you're having flame sense problems, especially if you have the voltage required. All right, let's talk about the airflow side. So we're going to look at blower amps, right? What does it actually take in to run that guy? And then, of course, system CFM. On most of the furnaces these days, we're telling you the CFM. You can also use the tables in the guide. So if you know the static number, you can go to the guide and say, okay, at a 0.7 static, this furnace is going to make 650 CFM or whatever that looks like. So pulling static info is going to be advantageous here. So on a gas furnace, we don't, the manufacturer doesn't know what coil is going to go on it. So we're always just going to go across the furnace itself. And in this example picture, there is no coil. So we're simply going to go return air after the filter. And then we're going to go the supply air after the furnace. It is the factory actually pulls them after the filter and then at the high limit. That's okay to do even with a coil on top, right? So if that is easier, do it that way. Air handlers, it's inlet to outlet, right? So after filter, at the inlet, and then after heat strips, if it has it, because the coil is already taken into consideration from the manufacturer. So air handler is a little different than gas furnaces, but we're simply looking at total external static before the coil, after the filter, across the gas furnace, or across the whole air handler. Okay. So we're going to write that information down because that's going to tell us a lot. And of course, use provided documentation, right? So on these UH models, they're speed taps, PSC motors, they're going to give us a lot of data, right? So if we're using a B60 high, we're going to use black. We have a 0.5 static. We know we should be able to make 1144 static at 0.5. Right, so in reference to the S8X, so this is a newer furnace, constant torque, short. At a 0.5 static on tap 5, we're moving 1123. So let's say we're running tap 5 for heat, and we have a 7 static. We know we're moving 1001 CFM, right? So we do the math as much as we can for you guys. Okay, furnace temporize, right? So lastly, what we're looking at is what is it doing? What is the actual return air what is the return air coming in and what's going out? What is being supplied to the home? What's our temperature difference or temporize, right? That can tell us a lot. Okay, we're riding on the high end of that furnace's limit. So we need to either look at ductwork or add maybe more blower, or here's the direction we need to go down, right? So there's instances where, high statics in home happen. Or howling returns or something like that. So we can take this data and go, okay, we're staying within the furnace running parameters, minimum and maximum, but we have these other issues, a howling return or homeowner noise and a register boot. So, okay, knowing that we're on the high end of that temporize, we can't slow down that blower because then now we'll have an overheat situation, right? So all this data collected is going to give us a lot of information. Okay, so always compare it to the manufacturer's information, right? So we'll pick on an S9V2 furnace, 60,000. This is a downflow model. We're telling you capacity in first stage, second stage capacity. We're also giving you first stage heating airflow, right? So we're gonna have low, medium, medium, low, medium, and high. So depending on how we're set, let's say we're set for medium, we're giving you a temporize. Right, we're saying that furnace should have a 40-degree temporize at a 0.5 static, and we're also giving you watts of the blower motor, and we're also giving you the CFM generated. So at a 0.5 static on medium, we're moving 903 CFM. We should have a 40-degree temporize. So, so we're giving you all the information. So temporize range just for equipment is on the model and serial number sticker. The main sticker should be there. This should also have LP and NG pressures first and second. That is a UL listing requirement to put it on the manufacturer's label. So use everything in the install and service facts to bring the data home for you. Some of it you're gonna have to get yourself because the manufacturer doesn't know what the duct system it's gonna be tied to, right? Doesn't know if it's a gas furnace and coil, what coil you're gonna mate it up with. So we're gonna have to collect this data. So the question is, why are we taking the cover off on 40-inch models to check pressure? If you take the cover off, you don't need to reference the burner. But if you have the cover on, you have to reference the burner because there is a pressure differential going to the gas valve when the burner door is shut. So that's why. So if you're taking the cover off, you don't have to reference the burner. Yes, a dual port pressure tester manometer can be used instead of slope. It's just a picture. So absolutely.